Hello. In this lecture we will discuss two interdependent extensions. We have the IKE CFG and XAUTH extensions. The IKE CFG protocol provides a framework to negotiate and generate security associations. While negotiating SAs, it is sometimes quite useful to retrieve certain information from the other peer before the non-IKE CFG SA can be established. Luckily, IKE CFG is also flexible enough to provide configuration information and do it securely. A configuration transaction is defined as one or more transaction exchanges, each consisting of two messages. The first is either a set or a request, and the second is either an acknowledge or a reply, respectively. The request reply allows a host to request information from an informed host, which we will refer to as a configuration manager. If the attributes in the request message are not empty, then these attributes are taken as suggestions for that attribute. The reply message can return those values, or return new values. The reply may also add new attributes that were not included in the requested attributes. A reply will always be sent when a request is received, even if it is an empty reply or if there are missing attributes in the reply. An empty reply means that the requested attributes were not available. The set and acknowledge response replies works on the push principle. This allows a configuration manager to start the configuration transaction. The configuration manager sends attributes that it wants the peer to alter. The acknowledge response returns 0 if the set request was accepted. If the client didn't accept any of the set transaction, it will not return anything. Transaction exchanges are completed once the reply or acknowledge message is received. The initiator and responder are not necessarily the same as the initiator and responder of the IKE CFG exchange. A new exchange mode is required for the configuration method. This exchange is called the transaction exchange and has a value of 6. This allows for multi-exchange transactions instead of being a one-way transmittal of information. After an IKE CFG security association has been established and SKIDE and SKIDA have been generated, the last couple of messages in the exchange, if main mode is used, is message 5 and message 6, which basically contains the identity proof. The IKE CFG transaction exchange would use the hash payload containing the proof output and the message ID unique to this exchange, and will concatenate it with all of the payloads after the hash payload. It will hash this using SKIDA. The initiator encrypts using SKIDE and sends the message to the responder. The responder gets the message and decrypts it using SKIDE. It will then extract the header. It will then do the hash validation and extract the attribute requested. It will then gather the reply and will do the same thing in reverse, sending it to the initiator who would extract the answer. A new payload is defined to carry attributes as well as the type of transaction messages. The next payload identifies the payload type of the next payload in the message. If the current payload is the last in the message, then this field will be 0. Configuration message types includes the configuration request, reply, or set and acknowledge as seen in this slide. The configuration attributes fields has 0 or more IKE CFG attributes requested. Zero-length attribute values are usually sent in a request only. Some of the configuration attributes includes internal IPv4 address and internal IPv6 address. This address is sometimes referred to as a red node address or a private address used for the IPsec communication inside the tunnel. Multiple internal addresses can be requested by requesting multiple internal address attributes. The responder would only send up to the number of addresses requested. The requested address is valid until the expiry time defined within the internal address expiry attribute, or until the ISA-CAMP SA that was used to secure the request expires. The address can also expire when the IPsec Phase 2 SA expires, if the request is associated with a Phase 2 negotiation. The attribute internal IPv4 DNS and internal IPv6 DNS specifies an address of a DNS server within the network. Multiple DNS servers can be requested. The responder may respond with 0 or more DNS server attributes. Internal IPv4 NBNS as well as internal IPv6 NBNS requests an address of a NetBIOS name server within the network. Multiple NBNS servers can be requested. The responder would respond with 0 or more NBNS server attributes. Only one attribute can be present in the reply. An implementation can support the attribute of internal IPv4 DHCP or internal IPv6 DHCP. This instructs the host to send any internal DHCP requests to the address contained within the attribute. Multiple DHCP servers can be requested. The responder can respond with 0 or more DHCP server attributes. The attribute internal IPv4 subnet is the protected subnetworks that this edge device protects. This attribute is made up of two fields, the first being an IP address and the second being a netmask. Multiple subnetworks can be requested. The responder can respond with 0 or more subnetwork attributes. Those are the subnets in Phase 2, which means those are the subnets protected by the Phase 2 communications and are used in the exchange for quick mode. The supported attributes type when used within a request, this attribute must be 0 length and specifies a query to the responder to reply back with all of the attributes that it supports. This will provide the initiator information about attributes it can request. Requesting an internal address. This function provides address allocation to a remote host trying to tunnel into a network protected by an edge device. The remote host requests an address and optionally other information concerning the internal network from the edge device. The edge device procures an internal address for the remote host from any number of sources such as a DHCP or BOOTP server or its own address pool. The edge device can also send other attributes that were not included in the request and can ignore the non-mandatory attributes that it does not support. We will discuss more in the next lecture.